Hi students to 910 double integrals. So this is a special section where we are going to focus on finding the volume of a solid in three-dimensional space. Why is that? Because we're going to go back again to the work done. So in this section, there will be no work done. All what we're going to do is we will find the volume of a solid in three-dimensional space. All right. In calculus, you learned that to find the area, what does this integration represent? This is exactly the area under the curve. It's the area under the curve. Let's suppose this is our curve here. This is f of x. This one is the x-axis, and this is the y-axis. This integral represents the area under the curve, which is between the curve f of x, this is f of x, and the x-axis from A to B. Here is, for example, on the x-axis A, and here is B. So this integral represents the area between our function f of x, which is the curve here that you see, and the x-axis. So here is this area from x equal A to x equal B. This is exactly the area that we're looking for. This is the meaning of the integral. So the integration of one-dimensional integral represents the area between a function and the x-axis from x equal A to x equal B. All right, now, what if we have a solid? Now let's suppose that f of xy, remember f of xy is what? Z equal f of xy. This is a solid. In what? In three-dimensional space. In three-dimensional space, we usually don't focus on the area. There is nothing called area. There is something called surface area. But I'm not going to find the surface area. I'm going to find the volume, okay, of the surface of the solid that is presented by z equal f of xy. So remember, we had these, and we graphed so many functions like the paraboloid, the sphere. All of those are surfaces and solids. How can we find the volume of the solid using double integral? Remember, guys, the volume of any solid is the area of the base times the height. It's always area of the base times the height. All right, let's start from that point and see how can I present this one on the curve and in the integral. Now let's look at this one. So what happens, every solid here, we're going to project it on the xy plane. The projection of the solid on the xy plane is going to construct that region. You see here, here's the region that we are talking about. Here is the base of the solid. The base of the solid is going to sit on the xy plane. As you see, this is the x-axis, and this is the y-axis. So this is our plane. This is the xy plane on the ground. The solid is going to sit on the ground. What we're going to do, we will find the area of the base using double integral. Remember in the previous one? So we are going to use double integral to find the area of the base. Who goes inside the integral? It's the height, which is z, our z function, that the surface on the top is the z function. So the z function is going to be presenting the upper part of the solid. And on the ground, I'm going to project the solid on the ground and see what is the shape on the ground. The shape on the ground is going to be in the XY plane and can be any kind of shape. Today, we're going to focus on a special kind of shape and region in the XY plane. So this is our region that you see on the ground that I surrounded with red. This is our region, and this region comes in the double integral. What we're going to discuss now, this is easy to know. Just put Z inside. The question is, what's the area of that region? And accordingly, we will put the limits of integral of the double integral. I will show you how. This region on the ground can be of two types. It can be of two types, guys. Type number one, region of type number one, whenever what? Whenever on the x-axis, it's a straight line. As you see, it's a straight line on the x-axis from what? From A to B. So these two boundaries on the x-axis are like straight line. On the y-axis, they are curves like y equal g1 at the bottom and y equal g2 on the, so the top and the bottom of the region is curves, functions, while the sides are what? Are points. And by the way, the shape can be like this too. We can say, for example, like that and like this. So here's our region. You see? So on the x-axis, they can be, here is A and here is B, here is G1 and here is G2. So it could be top and bottom, and they intersect, by the way. So it doesn't have to be always be a straight line, but if in the x-axis they intersect at A and B, so we find those intersection points and we put them on outside. And dx goes outside, guys. Region of type 1, we start with dx, that is points A and B. For y, goes inside, and what do we write? Who goes at the bottom? The function at the bottom is G1, so goes down, and the top one is G2, goes here on the top. That's it. This is how you set up your volume. The inside is going to be the top of the surface, which is going to be Z as a function of X and Y, but the base is a region in the XY plane of type 1. Also, the region of type 2 can be the opposite. On the y-axis, from C to D, so this is the region, by the way, so it's from here to here. This it is. This is it. From the top and the bottom, it's from C to D, and if it's region of type 2, we put outside dy, and we say from C to D from the outside. Now inside, we put dx, and we know, look at this. So the inner one, this one is h1 of x. Sorry, h1 of y. Because now we have to make it x as a function of y. So this is x as a function of y. And this one, x equal h2 of y. So from the extreme left, you start with this one first, in the integral down, and then this is second. All right. So now the sides are going to be functions of y, and the top and bottom from C to D. This is a region of type 2. Once you decide what is your region, just finish it and finish the integration, and this will give you the volume. That's it, guys. This is the topic in this section. How do you find the volume of a solid? Z equal f of xy, or the surface. Basically, project the surface on the ground and see how does the projection look like. It has to be either type 1 or type 2. That's it. Let's start and see what happens here. Here it is. First, he said, sketch the region of integration. You see, this is the integration. So he wants just to sketch the region. So look, if you look carefully, I have dx dy. Let me take you a little bit back. Whenever you have dx dy, this is a region of type 2. dx dy is a region of type 2. So you have to understand that your sector is going to be horizontal. By the way, I have to mention something also. When it's a region of type 1, you always take, it's like a scanner. You know, when you go to the scanning machine, what happens when you push the button? What happens? The light will come out, right? The light will start from here, from the extreme left on the scanner and on the printer, and it will start moving in this direction, isn't it? So it's going to be a vertical light. This light is going to move all the way to what? To here. In this movement, the light is going to cover what? All this area. But the light can go to infinity up and down. I need to bound it also up and down. So what's the bound at the bottom? G1. What's the bound on the top? So as long as this light is moving, always the bottom is G1 and the top is what? G2. In region of type 2, you take what? You take a horizontal light. So the scanner now is going to start from the bottom, going up. From where? From C to D. So the light is going to start from the bottom, go all the way up. This sector is going to continue up all the way to cover the whole region. But you need a bound from the right and the left. Who's on the left? It's H1 of Y. And who's on the right? It's H2 of Y. All right. So this is something we have to keep in mind. All right. So in this question, I have dx dy. Then I know that this is a region of type 2. He says sketch the region. It is a region of type 2. Okay, so what do we do, guys? Let's start from the outside. dy is, so we know that y is from 1 to y equal to what? 4. I'm going to make my graph. Here is the graph. It says from y equal 1 to y equal 4. So since I used the red one, I'm going to continue with the red. Y equal 1, here it is. So y equal 1, by the way, is a line, isn't it? This is y equal 1, 2, 3, and 4. So this is y equal to 4. Those are the bottom and the upper boundaries. So this is y equal to 1 up to y. Oops. Let me take the pen, yeah. Up to y equal to 4. Beautiful. So it's lines. Region of type 2, remember, you have to have horizontal lines. Now let's look at x, guys. Let's start. X starts from where? X starts from negative y, sorry, minus root y, up to x equal root y. What does this represent, by the way? In either cases, take anyone you like and square it. So I'm going to take x equal minus root y. Square both sides, guys. What do you get? So x squared is equal. If I square the minus, becomes positive. What's the square root of y? We know it's y, right? So this is nothing but y equal x squared. Let's graph it. Here's the second function. Y equal x squared. This is y equal x squared. Now, I know that I have a region of type 2. That means, now, it says from x equal minus root y to x equal root y. By the way, if y is equal x squared, if I want to go back, what does that mean? Take the square root of both sides. So y equal x squared. Now, take the square root of this and take the square root of that. What's the square root of x squared? It's absolute value of x equal to what? Square root of y. What does that mean? That means x is equal root y and x is equal what? Minus root y. So this part, by the way, is x equal minus root y, and this part is x equal actually root y. Altogether, what is this? Altogether, this one, y equal what? X squared. This is our curve. But the right side is x equal root y, and the left one is equal. And by the way, this one is h2 of y, and this one is what? Is h1 of y. The left one is h1 of y, and the right one is h1 of y. So where is my region, by the way? It says it's between minus root y and root y. So it's all of this curve. But it's from y equal 1 to y equal to 4. So where is my region? The region is going to be exactly this one. Just that part. See, this is our region. It makes sense. Look at this. Is it from y equal minus root x to y equal root x, which is, this is on the x-axis, x equal minus root y to x equal, and then y equal 1 to y equal to 4. So this is our region, by the way. You take any sector, any light, the light is going to start from the bottom. It's going to start from here, actually. And this is what? Y equal 1 all the way. It will move all the way up to cover this region. The light will continue going up to cover it all till he stops at y equal to 4. So the sector is going to start 1 all the way to 4. Fine. From the left and the right, does it go to infinity? No, it has a bound. The left bound is x equal minus root y, and the right one is x equal root y. So this is the green part is our region, guys. Alrighty, let's look at this one. It says, evaluate this. So this is a volume. Who is this, by the way? This is the surface. This is z equal x plus 1, where R is the region bounded by, let's look at number 1. Let's do number 1. Our region here is bounded by y equal x. Let's make the graph, guys, and see how the region looks like. Y equal x, it's that one. So let's do the first one in blue. We need to be patient, put the colors to see exactly where is finally our graph gonna end up. Where is the region? So this one, number 1, this is y equal x. The second one is x. Let me change the color here so we can see the next one. It's x plus y is equal to 4. That means y is equal minus x plus 4. That's a straight line, right? If I take x to be 0, then y is 4. So let's take x 0, then y is 4. So when x is 0, y is 4. And this is what we call the y-intercept. 1, 2, 3, and 4. Here it is. So this is 1 point, 0 and 4. Now let's take y equals 0. This implies that x will be what? Will be 4. So when y is 0, x is 4. Where is it? 1, 2, 3, and 4. That's the other point. Connect those two with a straight line. Here is, guys, this one, x plus y equal 4, or y equal minus x plus 4. So now I have 2 lines. The third one is x equal to 0. X equal to 0. Where is x equal to 0? We know x equal to 0 is who? This is the y-axis, isn't it? Y-axis. So this is, by the way, x equal to 0. Where is the region that has 3 colors in them? It's exactly this one, guys. That's our region. Isn't it bounded between the 3? Yes. It's bounded between y equal x, y equal minus x plus 4, and this one is x equal to 0. This is the region that is bounded between these 3 lines. Now we need to integrate. So he says integrate, find the volume, equal integration over the region of x plus 1 dA. All right, now let's find what kind of region is that. The best region to take it is to take it a region of type 1. So look what I'm going to do now. I will take a sector. Here it is. Imagine this is the light. The light is going to start from here, and it will keep on moving till it finish where? Here, right? So this one, since I take it a region of type 1, then I know in the integral, what do I say? I say x plus 1, then what? dy dx. I'm considering this as a region of type 1. Region of type 1 means dy dx. So start with x, guys. This light is going to start from where? This is x equal to what? 0 to x equal what? What is this point here? We're going to stop here, isn't it? Exactly. What is this point? This point is the intersection between those 2 lines, isn't it? What's the first line? Y equal x, and y equal what? Minus x plus 4. Make them equal, since the left is equal to the left. So that means x is equal minus x plus 4. Move this here. So 2x is equal to 4. Divide by 2. So x is equal to 2. So this one, guys, here is 2. So what's going to happen? our light, the vertical light, is going to start from 0 to what? It will stop at 2. The vertical light is going to stop at 2. Now, the vertical line can goes to infinity, but I don't want it. I need upper and lower bound. Who's at the bottom? Y equal to what? Y equal to x. Who's on the top? Y equal to what? Minus x plus 4. That's it. This is exactly how you do it. Now, let's see how do we integrate, guys. Now, let's work on the integration. How do we integrate this one? We start from inside and we go to the inner integral. So we are going to integrate with respect to y. Okay. What's the integration of x with respect to y? X is constant now. So this is equal to integration from 0 to 2. Then open the box again. The integration of x with respect to y, x is constant. So you only integrate dy. We know that the integration of dy is y. So you have x, y, plus, what's the integration of 1 with respect to y? It's a y. And this is from where? From x to minus x plus 4. We close this one and we say dx. So we integrate with respect to y, and then we plug the upper limits and the bottom one. So this is equal to the integration from 0 to 2. Now, let's open the box again. We plug each y with minus x plus 4. So this is x times minus x plus 4. Minus, now what do we replace y with? X in both of them. Of course, don't forget plus minus x plus 4. So I plug it here and here. Minus now, open bracket. Now we replace x for the y. So we have x times x plus, we plug the x here too. So you get x. We close and we say dx. And this is equal to the integration from 0 to 2. This one is negative x squared plus 4x. Then minus x plus 4. And this one is minus x squared minus x dx. And this is equal to the integration from 0 to 2. Now minus x squared is minus 2x squared. 4x minus 2x is 2x. Finally, plus 4, here's plus 4. All of that dx. Now we can integrate. The integration of x squared is x cubed over 3. So this is minus 2x cubed over 3 plus the integration of this x is x squared over 2. The 2 goes with this 2, so you have x squared plus the integration of 4 is 4x, as you know, and this is from 0 to 2. What do we plug first? The 2. So it will be negative 2. If I put 2 here, we'll get 8 over 3. Plus, put the 2 here, you get 4. Put the 2 here, you get 8. Minus, if I put the zeros, all will be zeros. So this is negative 16 over 3 plus 12. 12 times 3 is 36. So this is minus 16 plus 36 over 3. 36 minus 16 is 20. So you get 20 over 3. This is exactly the volume of the solid that is bounded above by z equal x plus 1. And on the ground, it is standing on this shape. That's it. Number 2. Same solid, same surface, but the ground now is different. What do we have on the ground? Number 2. We have y equal x squared, x equal to 0, and y equal to 4. Okay, let's graph the region. Y equal x squared, let's start with the first one. This is the first one. Y equal x squared. The second one, so this is y equal x squared. Now the second one is x equals 0. We know x equals 0 is the y-axis. So this one is x equal to 0, guys. It's the y-axis. You can go all the way down, by the way. This is the y-axis, and this is x equals 0. And y equal to 4. Y equal to 4. Here is 1, 2, 3, and 4. So the last one, we're going to make it blue. Here is 4. This is y equal to 4. Now, I should add something here. This is in the first quadrant. The question has to have this statement. It's in the first quadrant. First quadrant, by the way, here is the x-axis. This is the first quadrant. So my region is here, guys. Got it? So the volume is equal to double integration over R of x plus 1. Now it's up to you to decide what type of region you want to take. It's easy. You can see I'm going to take what? Region of type 1. I'm going to take region of type 1. I will take the light to be what? To be vertical. So it's going to start from where? From this one is x equal 0. So I'm going to say x plus 1. This is not x plus y, x plus 1. Then I'm going to say dy dx because I chose it to be region of type 1. So it's going to start from 0 up to where? It's going to stop here, isn't it? This is the final thing. This is the final stop. On the x-axis, what is this x on the x? When I stop here, what is it on the x-axis? It's the intersection of what? Look at this. You have y equal x squared. This is the red one. And y equal to 4, isn't it? So that means x squared is equal to 4. Take the square root of that, so it's plus minus 2. So this is 2, by the way. And this is here is negative 2. But I don't need the negative 2. I need the 2. So on the x-axis, I'm going to start from 0 to 2. It's the vertical movement from left to right. So the scanner is going to cover all this region, keep on moving, and it's going to stop here. When it stops here, what is it on the x-axis? It's 2. When it started here, what was it on the x-axis? It was 0. Beautiful. Now this vertical sector, light, has length. Who's at the bottom? We know this is y equal x squared. Who's on the top? We know this is y equal to 4. That's it. Bottom and top, right and left, done. Now let's integrate with respect to y. Same thing. So now this is equal x, it's the integration from 0 to 2. What I'm going to do is I will put here a box to see that we are going to start from inside. So the integration, so let me open the box now. And if you remove the x. We open the box and now we integrate. It's the x, y plus y. The x is constant. We integrate with respect to y. So we don't think of x, just copy it down. What's the integration of, when you take the x out, the integration of dy is y. Plus, what's the integration of 1 dy? Again, it's y. And this is from x squared to 4. We close the box and we say dx, which is equal to the integration from 0 to 2. Open the box. Now put the 4 for y, guys. We are talking about y now. So this is 4x plus 4 minus. Now we put x squared here. So what do you get? X cubed plus x squared. You replace x squared here, you get x squared times x is x cubed. Then you put it here, you get x squared. Here it is. All of that dx. And this is equal to the integration from 0 to 2 of 4x plus 4 minus x cubed minus x squared dx. Now what do? We plug we integrate. So the integration of 4x is 4x squared over 2. Plus the integration of 4 is 4x minus the integration of x cubed is x4 over 4. The integration of x squared is x cubed over 3. And this is from 0 to 2. Now what do? We plug the 2 first. By the way, this one with this one is 2. So you have 2 times 2 squared is 4 plus 4 times 2 minus 2 to the 4 is 16 over 4 minus 2 to the 3 is 8 over 3 minus, now if you put the zeros, you would get nothing but 0. And this is equal to, this is 8 plus 8 minus 4 minus 8 over 3. This is 4 and 8 is 12. So this is equal to 12 minus 8 over 3. 3 times 12 is 36 minus 8 over 3. And this is 20. 36, if you remove 8, you get 28 over 3. That's the answer. This is exactly the volume of this solid. Same solid, by the way, but on the ground, it's standing on this shape that you see on the right. All right, now, what do we need to do here? We need to evaluate. Okay, we're done with these two guys. All right. All right. Let's find the volume of the solid bounded by the given functions. Z equal x plus y. By the way, don't worry about this one because this is the inside. Then you have what? You have this, this, that, and this in the first octant. So now Z is equal x plus y. This is the integration. So the volume will be double integral on R. Who goes inside always? Z, right? Which is f of x, y. So x plus y. Then we say what? dA. Now, let's look at the region, guys, that he's giving me. The first one I'm going to take is x squared plus y squared equal 9. What do we know about this one? This is a circle of radius 3, isn't it? Okay, let's graph it. So I'm going to make this one in the red color. 1, 2, 3, 1, 2, 3, and then 1, 2, 3, 1, 2, 3, and you make a circle of radius 3. Here it is. All right, this is the first thing. The second one is x equal to 0. Where is x equal to 0? We know this is what, guys? The y-axis. So x equal to 0, here it is, guys. This is x equal to 0. It's the y-axis. Continues all the way down. This is x equal to 0. X equal to 3. Here is a 3, guys. So this is the end. So this is x equal to 3. It's this line, right? X equal to 3 is this line. So x from 0 to 3, mainly. Y equal to 0, we know this is the x-axis. Where is the x-axis? Here is the x-axis. So this one is y equals 0. It's the x-axis. And it continue, of course. But I need it from x equal to 0 to x equal to 3. And it's in the first octant, means in the first quadrant, by the way. So you should be here only. So where is it? Look at this. Here is the circle. x squared plus y squared equal to 9. This is x equal to 0. This is y equal to 0. And this is x equal to 3. So where am I? This is my region. Only that part. That's it. Now let's take it as a region of type 1. So what do we take? We take a vertical sector. Let's take a vertical light. The light is going to start from here. From where? So this is the integration of x plus y. Since I decided that it is a region of type 1, so what do I say? dy dx. So the light for the x is going to start from 0, as you see, and it will keep on moving, and it's going to stop here. Where is this at? 3. So it's from 0 to 3. So the vertical light starts from left to right. Now, what is the length of this light? Who's at the bottom? Always the light touching who? Touching the x-axis, which is y equal to 0. So in the bottom, y is equal to 0. Sorry, this is a 3. How about the top? Who's this? This is x squared plus y squared equal to what? 9. But I need y. So I'm going to take it here. So x squared plus y squared equal 9. So y squared is equal 9 minus x squared. So what's y equal to? Plus minus square root of 9 minus x squared. By the way, the top one, this is not anymore. So this actually is the positive part of 9 minus x squared. And all the bottom here is y equal minus 9 minus x squared. So the upper half of the circle is the positive radical, and the bottom one is the negative radical. So the top is square root of 9 minus x squared. That's it. I just set up my work. By the way, now you ask yourself, what about z equal to 0? Look here, guys, when you are in three-dimensional space, here is the three-dimensional space. It's y, z, and x, right? As long as you are in the xy plane, look at this. This is the ground. Can you imagine? This is your ground here. As long as you are here, you know, you're neither up nor down. So we know as long as you're here, what's z? Z is equal to 0. So he wants us to find the volume of the solid where this solid, by the way, z equal x could go down, but I don't want to go down. I'm going to what? Cut it at the bottom at z equal to 0. So I need the ground to be the xy plane. Here is the y, and here is the, this is the meaning of it. So what do we mean by z equal to 0, by the way? So z equal to 0 is the xy plane. As long as you are on the ground, z is equal to 0. So the solid is not going to go beyond the xy plane below it. So it's always above it. That's it. Now let's integrate. We're going to start integrating by y. So what do? We put a box here, and we start integrating from inside. So what is this equal to? The integration from 0 to 3, and let's open the box. What's the integration of x with respect to y? It's xy plus, because x is constant, we just integrate dy. What's the integration of y with respect to y? It's y squared over 2, and this is from 0 to square root of 9 minus x squared and dx. Now what do? We plug the top one. So this is equal to the integration from 0 to 3, and we open the box. Now we replace y with 9 minus x squared. So this is x 9 minus x squared plus, put the y here now. If you square this, you get what? 9 minus x squared over 2. Then we close and we say what? dx. All right, which is equal now, integration from 0 to 3 of x square root of 9 minus x squared dx. I'm going to split it, plus the integration of 9 over 2 dx from 0 to 3 minus the integration of x squared over 2 dx from 0 to 3. So you see, I'm going to split the integral. Now, how do you integrate this one? This is the question. This can be done by substitution, by the way. So with the limited space, I will have to probably erase some of the things which we don't need. Let me erase that one. This is the XY plane. We understood this one now because I need the space now. So what do? We do the following. Let's find how can we integrate x square root of 9 minus x squared dx. Here you can let u equal 9 minus x squared. So what's du over dx, guys? It's negative 2x, isn't it? Bring dx here. So du is minus 2x dx. What do I have, by the way, inside? I have x dx. So I'm going to divide by negative 2. So du over negative 2 is x dx. So what's my question going to be? It's the integration. Look at this. I took the square root of u. I took the inside u, right? This is u. Now x dx is du over negative 2. du over negative 2. Take the negative half outside. So what am I left with? U, this is u to the half, du. And this is equal to minus half, goes outside as you know. The integration of this one is u to the 3 over 2. You increase the power by 1 and you divide by 2 over 3. This 2 goes with this one. And this is equal to u to the 3 half over 3 with a minus. But what's u? U is 9 minus x squared. So the answer is 9 minus x squared to the 3 half divided by negative 3. So the answer for this one is negative 9 minus x squared to the power 3 half divided by 3. Plus, what's the integration of this one? 9 over 2x minus, what's the integration of x squared? It's x cubed over 3, but at the bottom there is 2, so it was 6. And this is from 0 to 3. If you plug the 3 guys first, what do we get? We get minus 9 minus, put x3, you get 9 to the 3 half over 3, plus put the 3 here. So this will be 27 over 2. I think we don't need this 2. So let me erase this my way. And the last one, if I put 3, it's going to be 27 over 6 minus 27 over 6. Minus, if you put the 0, minus, start with 0. 9 minus 0 is 0. So this is going to be minus 9 to the 3 half over 3. And then if you put 0 here, it's 0, and that's it. So we close that one. So this is going to be 0. Then 27, if you multiply by 3, 60, 81. So this is 81 minus 27 over 6 minus, by the way, 9 is the 3 square. Raised to the power 3 half. 2 goes with 2. So you get 27. So this with this is now plus 27 over 3. All right. So this is what we have so far. And the least common between, so this one, let me find 27. So we have 81 minus 27 is 54. So we have 54 divided by 6 plus, if I multiply this by 2, multiply 27 by 2 is 54. So this is going to be 108 over 6, which is equal to 18. This is, guys, the volume of this solid. Could be centimeter cube, could be centimeter meter cube, whatever the unit is. All right, so this is the volume of the solid. Now, find the volume of the solid bounded by these. By the way, here is there is an error here. I will have to fix that part. So let's take the black. There's nothing here. It's 2x plus y plus z equal to 6, x equals 0, y equals 0, z equals first octant. So now what we have here, guys, we have this function. Now it's probably you need to graph this one. So you have 2x plus y plus z equal to 6. This is easy to graph, by the way. So I'm going to show you the graph of this function. Now we are in three-dimensional space. Now, guys, I'm going to graph. This is the first time we are going to graph the solid. All right, how do we graph it? I'm going to let x equal y equal 0. So what does this imply? That z is equal to what? 6. So what's the point here? 0, 0, and 6. So I'm going to go 1, 2, 3, 4, 5, and 6. Here is the point, by the way, 0, 0, and 6. Now I'm going to let x equal z equal 0. So what do we get? We get that this is 0 and this is 0. So y is equal to 6. So we have 0, 6, 0. Here's 1, 2, 3, 4, 5, 6. So this is 0, 6, and 0. Now let y equals z equals 0. So what do we get? So we get 2x equals 6. So this implies that x is equal to 3. So what's the point here? 3, 0, and 0. So on the x-axis, 1, 2, and 3. And this is the third point. I'm going to connect those points with lines and see how the shape look like. Look at this, guys. I'm going to go all the way down to this point. And here, all the way down to the next point. And here, all the way down. So what do we have, guys? We have a pyramid. So the shape of that one is a pyramid. But the pyramid gonna extend, by the way. So it's not pyramid on it goes right, left, everywhere. So it's still going. But what's gonna happen? Look what's next. It says x equal to 0. In three-dimensional space, when I say x equal to 0, what does that mean, guys? This is the YZ plane. Where is the YZ plane? Here's the y-axis, by the way, and here's the z-axis. So this is the YZ plane. The YZ plane is going to come and cut it from the back. So now this is the back side of the solid. It's been cut from the back. The next one is y equal to 0. When I say y equal to 0, this is the XZ plane. Where is XZ? This is the XZ plane, by the way. See that? So this is going to come and cut it. So now I have this face. And finally, Z equal to 0. Who's that? This is the XY plane. Who's the XY plane? Here it is on the ground. See that? This is exactly Z equal to 0. And this one is Y equal to 0. And this plane here is Z equal to 0. So this is Z equal to 0. So this is X equal to 0. So these three, it's going to be in the first octant. This is the first octant where everything is positive. X, Y, Z are positive. So the shape is going to be here. So at the bottom, it will be cut. So this is our base. See, so it's a pyramid. Exactly. Cut it from the bottom, from the left, and from the back. So you get this beautiful shape. And you need to find the volume of this shape. And by the way, it comes here also. It has a face here on that side, right? On this long one, we do have a face in the side. So it has 4 faces. This one, the bottom one, and the one that comes in our side. How do you find the volume? Very easy. It's double integration of the region of what? Of f of x, y, f of x, y, sorry, which is, you can say z, d what? dA. Now, what's f of x, y? F of x, y is z. So let's look at here, guys. What is z from the question? You have z is equal to what? Move everything to the other side. So it's going to be minus 2x minus y plus 6, isn't it? So this is what's going to go inside. It's the z, which is minus 2x minus y plus 6. That's what goes inside. Now we say this one is dA over R. The question is, where is R? Let me shade R for you. Where is the base of this solid? This is the base of the solid side, guys. This is the ground. The solid is standing on the XY plane. So this is our R. It's the base of the solid, right? This is our base. What do? I'm going to take this one here on the side and graph it to see if it's type 1 or type 2. So what do we have here, guys? Y is up to what? Y is up to 6. So you have 1, 2. So let me fix it better so I can have space. Okay. All right. So here it is. Y is 6, 1, 2, 3, 4, 5, and 6 on the y-axis. And x is a 3. You see, this is the x-axis, and it's 3. So here's 1, 2, and 3. So this is the point. Connect these two guys. So this region, by the way, that you see here, the base, is exactly this one here. This is a 3, by the way. So what is this line? When you are on the ground, by the way, we know here, z is what? 0. Okay, but this is what? Isn't this 2x plus y plus z equal to 6? Right? This is the equation that we have at the bottom. So I need to find this one, but we know here that z is equal to 0. So what do we have? We have 2x plus y is equal to 6. Move this to the other y. So y is equal to what? Negative 2x plus 6. So this is y equal negative 2x plus 6. We got this side. So now I'm going to treat this one as a region of type 1, maybe. Let's treat it as a region of type 1. So what's going to happen? We're going to start from where? From x equals 0, and the scanner is going to move now to cover the region, and it's going to stop here. And what is this? 3. So look what I'm going to do. So this is equal to the double integration of negative 2x minus y plus 6. Now, I am going to consider this as a region of type 1, the base. So what do we say? dy dx, because I took it as a region of type 1. All right, x is from where to where? From 0 to 3. How about the y? What is the bottom of this scanner? This slight vertical line. What does it start with? This is y equal what? 0. So from y equals 0 up to y equal to what? Minus 2x plus 6. This is how you set up your integral. And of course, now you integrate from inside. And this is equal to the integration from 0 to 3. Let's integrate with respect to y, guys. What's the integration of this one with respect to y? So open bracket. So this is minus 2x, y. We treat x as a constant and the 2 as a constant. Minus, what's the integration of y with respect to y? It's y squared over 2. What's the integration of 6? It's 6y. And this is from where? From 0 to minus 2x plus 6. We close and we say dx. Now what do? We replace every y with minus 2x plus 6. So this is going to be minus 2x, then minus 2x plus 6 minus 2x plus 6 square divided by 2 plus 6 times minus 2x plus 6, all of that. Then what do we say? We close and we say dx. Now we have to expand all of this. Okay, so this is equal to, I'm not sure if I have a space on the second one. We don't have a space for that one. So this is equal to the integration from 0 to 3. This is, open that one, you get 4x squared minus 12x minus, let's look what we have on the top. This is 4x squared times the first times the second times 2 minus 12x times 2 is minus 24x. Then the square of the last, which is 36 divided by 2. Now here, minus 2x times 6 is minus 12x. And 6 times 6 is 36. So plus 36. This is what we have. And we say at the end what? Dx. All right, I'm going to go all the way here up so I can use the space to finish the integral. Now, so you have the integration from 0 to 3 of 4x squared minus 12x. Now look what's going to happen. We know that this is 4. Where am I now? I'm here. So 4 divided by 2 is 2x squared with minus. So this is minus 2x squared. Now minus 20, minus with minus 24 is plus 24 over 2, 12. So plus 12x. Then 36 with minus is minus 36 over 2 is minus 18. Minus 12x, the last one, plus 36 dx. Alrighty. Now, what do we have for the x's and what do we have for the y's? You know, this one minus 12x will goes with plus 12x. And this is the integration of 0 to 3 of 4x squared minus 2x squared is 2x squared. Then what do we have? Minus 12x. Then we have 36 minus 18 is 18 dx. Now let's integrate. The integration of this one is 2x cubed over 3 minus 12x squared over 2 plus 18x from 0 to 3. You know, this one with this one is 6. Now let's put the 3, guys. So this is 2 over 3. If I put the 3 here, we get 27 minus 6 times 9. Because if I put the square here, you get 9. Plus 18 times the 3. So this is 54. And this is equal to, so I'm going to use my calculator here to get to the final answer. So 27 times 2 is 54 over 2. So we have 54 over 3 minus, what do we have? Is 54 plus 54. This one cancels that. And the answer is 54 over 3. This is the final answer of the integration. This is the volume of the solid. Okay, now it says here, reversing the order of integration. By the way, you are sometimes forced to reverse the integration from type 1 to type 2 or from type 2 to type 1. Or you have to choose the correct order. Why is that? Because sometimes when you put a dy over dx, you cannot integrate with respect to y. Or you make it dx over dy and you cannot integrate from dx. You see, because you have to integrate from the inside first. Sometimes the inside is not integrable. So what do? We will have to switch. Let's take these two examples, guys. Look at this. I want to integrate this one, where R is the region bounded by yx squared, x equal 4 in the first quadrant. So let's look at this one, guys. So we're going to integrate this one, x e to the y squared dA over R. Now, R is, let's graph the R. So this is good color. Y equal x squared. This is y equal x squared. X equal to 0. We know that x equal to 0 is the y-axis. This is x equal to 0. And y equal to 4. We grabbed this one before. Here is y equal to 4. And it's the first quadrant, it says. So you are here. Alrighty? So what can we take this one? By the way, we did this one before because this is, so this is 2. Okay, so what I'm going to do is the following. If we set it to be region of type 1, what's going to happen? So this is equal to the integration of x e to the y squared dy dx, and x is from 0 to 2. Remember, the sector is going to be what? The sector is going to be vertical sector, region of type 1. So this is going to be a vertical sector. So it's going to start from where? From 0 to 2. How about the length? Who's at the bottom? This is y equal x squared to the top, which is y equal to 4, right? Because this is our region. Y equal to 4. And what do we do now? We close inside and we say, okay, let's integrate with respect to y first. What's the integration? Now, x is constant. What's the integration of e to the y squared? You can't integrate it at all because you need the derivative of the power. You know, the integration of e to the u du is e to the u. This is what? If the derivative of the power exists, then you can do it. So when I say the integration of e to the y squared times 2y dy, I can integrate this one easily because the derivative of y squared is there. So the answer is what? E to the y squared. Why is that? Because how do you integrate this one? You let u equal to what? Y squared. So what's du? The derivative of y squared is what? 2y dy. So what's this going to be? This is going to be e to the u because I took y squared to be u. And 2y dy is du. See, now I moved it to here and the answer is e to the u. And u is what? Y squared. So in order to integrate the exponential function, the derivative of the power must exist. Here it doesn't exist. So this is impossible to integrate. So what do? Let me try to switch to region of type 2. So now this is a region of type 1. Huh? Now I'm going to switch to region of type 2. So I'm going to change the color, take the blue one, and I'm going to take my sector starting from the bottom and moving all the way up. Fine. So the light now is horizontal line. So this is going to be equal to the double integration of x e to the y squared. I'm going to make it dx dy because now I'm going to change to region of type 2. All right. For the y, guys, where does it start with? This is what? This is y equal to 0. I'm going to go all the way up till what? Till y equal to 4. So from the y, from 0 to 4. How about for x? What is this, the left? You see, the sector now is going to be like that. So it has a length from left to right. Who's on the left? X equal to 0. Here it is. So x starts from 0. To what? Who's this? This is y equal x squared. But you have to switch. You have to write it x equal to what? We know that this is x equal to what? Root y. And this is equal minus root y. Remember that? So x here is root y. So up to root y. So this light is going to start from 0 to y horizontally. Then on the length of it, from left to right, we know from the left here, x is equal to 0. Up to what? Up to this one. Who's this curve? This is y equal x squared, but I can't write y equal, it has to be x as a function of y. So x is equal to root y. So this is what comes on the top. Now let's see if this is integrable. What's the integration of that? So this is integration from 0 to 4. Now I'm integrating with respect to x, guys. So all of this is what? Constant. So don't worry about this one. So it's going to be e to the y squared. We don't touch it. It's a constant. I'm integrating with respect to x. What's the integration of x? It's x squared over 2. You see, now it's integrable from 0 to root y. And then we say all of that dy. Now we say equal integration from 0 to 4. What do? We plug root y for x squared. So it's going to be e to the y squared times what? Times y over 2 minus, we replace x with 0. So you get e to the y squared times 0 over 2. All of that dy. We know this is all 0. So what am I left with? It's an integration from 0 to 4 of e to the y squared times y over 2 dy. Now let's do this one by substitution, guys. Let u equal y squared. I'm going to take the power, call it u. So what's du? It's 2y dy. I have y dy, but it's divided by 2. So let's divide this by 2. Okay, or let's divide by 4. So du over 4. What is this going to give me? It's going to give me y over 2 dy, isn't it? If I divide it by 4. Look how beautiful it is. All of this is du over 4. So what's this going to be? So this is equal to, let's continue away. So the integration of e to the y squared times y over 2 dy is equal to the integration of e to the u. I took y squared to be u, and all of this is du over what? 4. Take the 1/4 out, so you're left with e to the u. What's the integration of e to the u? It's e to the u. So the answer is 1/4 e. What's the u? It's y squared. So the answer is e to the y squared over 4, and this is from 0 to 4. Now replace y with 4, so e to the 16 over 4 minus, replace the 0, e to the 0 over 4, which is e to the 16 over 4 minus 1 over 4. Take 1/4 outside, so the answer is e to the 16 minus 1, and this is, guys, the volume of this solid, whose height is this function, and the base is this one that you see here, region of type 2. Let's look at that one. He wants to integrate that one, by the way. So if you go back to the question in part 2, he says, evaluate this one by reversing the order of integration. So I need to reverse it. How do you reverse it? It's not an easy thing. You have to see the graph first. When you have dx dy, I know this is a region of type 2. He was considering the question as a region of type 2 because dx dy. Alrighty. So what do we start with? With the y guy. Y is from where? The outside, from 0 to 1. So in this integration, y goes from 0 to y equal to 1. Let's see how does this one go on the graph. Y equal to 0 is the x-axis, by the way. This is y equal to 0. Up to y equal 1, this is 1. So this is y equal to 1. So you are between these two guys, between this x-axis and y equal 1. Here is y equal to 1. All right, how about x? X goes from where? From 2y up to x equal to what? Who's on the top? 2. Where is x equal to 2? If this is 1 and this is 2, so this is x equal to 2. and x equal to y. Okay, how do you graph x equal to y? That's easy. Let x equal to 0, then y is equal to what? 0 for sure. So here's 1 point. If y is equal to 1, so x is what? 2. So you have 2 and 1. This is 2 and 1. Here it is. So this is actually the intersection point. Connect these two with a line. So who's this now? This is x equal to y. The question says, take y from 0 to y1. Here's y1. So you might think you're here. No, be careful now. And x is from x equal to what? X equal to this line to x equal to 2. Where is x equal to 2? Here is x equal to 2, isn't it? So you are here in this region. This is your region, right? X equal to y. And don't forget, this is region of type 2, isn't it? So actually the sector looks like this. It's a region of type 2. So our light is a horizontal line, right? Because this is a region of type 2. And this is my region, by the way, this one. So region of type 2 means I have to have horizontal line. What does it start with? On the y-axis, it starts with y equal to 0, goes all the way up. Where does it stop at? At y equal to what? 1, is it? So this is my stop from 0 to 1 on the y-axis. Okay, on the x-axis, who's on the left? This is what? X equal to y, isn't it? 2x equal to what? 2. You see that? From 2y to 2. This is the left and the right now. That's it. This is how. Now he wants me to switch. I don't like the horizontal thing. I need it to be vertical. So what do we do now? We change the color. Look, how do we switch? I'm going to make it a what? A vertical light. If I make the horizontal light vertical light, where do I start with? So look what I'm going to do. He says reverse. So, okay, I'm going to reverse. So it's e to the minus y over x. And instead of dx dy, I'm going to make it what? dy dx. Beautiful. Now, the light is vertical. What does it start from? It starts from here, right? On the x-axis, let's look at the x. Starts from 0 up to where? We're going to stop here, are we? So for the x is from 0 to 2. Now, this vertical line, what's the bottom of it? As long as it's walking, who's the bottom? This is y equal to what? 0. Up to, who's on the top? This is the top. This is y equal to what, by the way? This is x equal to y. So that means y is equal what? Isn't it x over 2 divided by 2? So up to y equal x over 2. So it's from x equals 0 all the way, stops at x equal to 2. That's vertical. And then who's at the bottom now? This is y equal to 0. Now, okay, what is this? This line, this slant is x equal to y, but I have to make it y as a function of x. So it's x over 2. That's it. This is what you get. Now let's integrate, guys. So to integrate this one, I'm going to choose different color to finish the integration. So what do? We close here and we close there. So this is equal to the integration from 0 to 2. I'm going to integrate with respect to y, guys. So look what we do now. To integrate this one, be careful here. E to the minus y over x dy. Now call this one u minus y over x. So what's the derivative of u with respect to what? With respect to y, guys. You know the derivative of y is 1, so this is minus 1 over x, isn't it? Beautiful. By the way, when you integrate with respect to y, you assume that x is constant. Now bring this one here. So du is minus 1 over x dx. In the question, so dy, there's no x here. du over dy, so this is what you get. In the question, I have only dy. So what I'm going to do, I will multiply the whole equation by negative x. So what do I have? So minus x du is equal to dy. So what's this going to be? So this is the integration of e to the u. What's dy? Minus x goes out dy, du, sorry. You see, I took the x out because I'm integrating with respect to y. So x is constant. You can kick it out. It's like any number, like 2 or 3. So the answer is negative x. What's the integration of e to the u du? It's e to the u. And the final answer is negative x e to the minus y over x. So this is equal, open box, minus x e to the minus y over x dx. You see, be careful about the integration. It's very sensitive. You are integrating with respect to y. So you let u equal minus y over x. The derivative of that is minus 1 over x. Bring dy here, I did. In the question, I have only dy. So I'm going to multiply by minus x. So minus x, here it is. So this dy will be minus x du. I can kick the minus x out because I'm integrating with respect to y. Now, so the answer is this. Now you continue. Now we need to integrate with respect to x, guys. How would you get this one now? To integrate this one with respect to x, we do the opposite. Now look what I'm going to do. I need to integrate minus x e to the minus y over x dx with respect to x. Now, there's a product of two functions, right? There is a product of two functions. So we should do this one by integration by parts, right? We can do this by integration by parts. I hope I have the question. I have this one. So what did I do? And yeah, it should be integrated by parts minus x. All right. Now we're going to integrate this with respect to x. Oh, yeah. My apology here. I didn't put the limits of integration. So this is from 0 to x over 2. I forgot to put the limits. So let's put the limits now. So this is equal to the integration from 0 to 2. Replace every y with x over 2. So this is going to be minus x e. If I put x here, what do I get? Minus x over 2 over what? Over x. I'm replacing y with x over 2. Minus x e to the, replace y with 0 now, you get e to the 0. All of that dx. And this is equal to the integration from 0 to 2, negative x e to the what? This x goes with that. So I would say this is e to the minus 2, minus e to the 0 is 1, so x dx. So I don't think now we need this anymore. Now distribute the integral. So this is the integration from 0 to 2, e to the minus 2 goes out, and you have with minus actually, so you have x dx. Then the minus goes out, x dx from 0 to 2. I distributed the integral. And this is equal minus e to the minus 2. The integration of x is x squared over 2 from 0 to 2, minus the integration of this one is also x squared over 2 from 0 to 2. So minus e to the minus 2, put the 2, you get 4 over 2, minus, and minus becomes plus, e to the minus 2, put the 0, you get 0 over 2. Minus, put the 0, 4 here, over 2, minus, and minus becomes plus, put the 0 over 2. This is 0, and this is 0. So you get minus 2 e to the minus 2, minus 2. This is the final answer. All right, let's do this integral now. How would you evaluate this? So it's a way of teaching you how to integrate with respect to x and y, guys. To integrate with respect to x, guys, you have to assume that y is constant. So we only integrate with respect to x. So what is this equal to? It's the integration. So let's integrate now. We don't touch the y, and we don't touch the 6. So 6y stays. What's the integration of x? You only integrate x as x squared over 2 minus 5e to the y x, because this is all constant, goes out. The integration of the x is just x. And this is from -1 to 3. We don't touch the y. Y is a constant, guys. This 2 with this one is a 3. So the answer is a 3x squared y minus 5x e to the y from -1 to 3. We plug the 3 now for, don't forget, for x. So this is a 3. If I put 3 here, it becomes 3 squared y minus 5 times the 3 e to the y. Then minus, what do you plug the 1? 3 times 1 square y minus 5 times 1 e to the y. Replace x, first 3, then minus, replace x with 1. 3 squared is 9 times the 3 is 27y minus 15 e to the y. This is going to be minus 3y. And this minus with minus is plus 5e to the y. 27 minus 3 is going to be 24y minus 15 plus 5 is minus 10 e to the y. This is the final answer. Let's do this question. Same thing, I need to integrate with respect to y, guys. So what do we treat x as? We treat it as a constant. So this is exactly as you can take x cube out, guys. Don't worry about it. So this is integration from 1 to 3x of e to the xy dy. Okay, how do you do this, by the way? What's the integration of e to the xy dy? You know, this is very sensitive. E to the x, y dy. What do we do? Let u equal x times y. I'm going to differentiate with respect to y. What's the derivative of y? 1. So what's left? X. So what's du? It's x dy, right? I have only dy, so I'm going to divide by x. So du over x is equal to what? Dy. So what's my question going to be? It's e to the u, I took this one u, then dy over dy is what? Du over x. X can be easily kicked out because I'm integrating with respect to y. Clear? So this is 1 over x. What's the integration of e to the u? It's e to the u. Now, so this is 1 over x. What's u? That's xy. So this is the result of the integration, guys. So this is equal to x cubed, open bracket. You're going to put the answer, which is 1 over x e to the xy, and this is from 1 to 3x. Now, we are going to replace each y with the 3x. So this is 1 over x e to the x times 3x minus 1 over x e to the what? X times 1. And this is equal to x cubed. 1 over x e to the 3x squared minus 1 over x times e to the x. Take 1 over x out, so you have x cubed times 1 over x. You're left with e to the 3x squared minus e to the x. This one cancels the cube, you get x squared e to the 3x squared minus e to the x. This is the final answer. See about the sensitivity here? You integrate with respect to y, so x is garbage. Just kick it out always. Look at this one. I need to integrate with respect to y. What do we do? Take the denominator as u. So let u equal x squared plus y squared. By the way, x is constant. We don't care about it, right? So we're going to differentiate u with respect to what? With respect to y, guys. What's the derivative of x squared with respect to y? 0. Plus, what's the derivative of y squared? It's 2y. Move this one here. So du is equal to what? 2y dy. What do you have in integration? You have xy dy. So look what I'm going to do here. See this x, I don't need it. I can kick it out. So this is 0 to 2x. Then what? 1 over x squared plus y squared. See this y, I'm going to put it with this. I can do that, right? It's the same thing. I put the y with dy. And I kick the x out. So I'm left with 1 here. So look what's going to happen. So this is equal x2. All right. Now, let's put the question now. So I'm going to integrate now 1 over x squared plus y squared and then y dy. You see what happened? I first kicked the x out. So now this is what you need to integrate. This is what I need to integrate. Okay. Now this is equal to, I took the denominator to be u, didn't I? Right? How about y dy? What's y dy equal to? Now, 2y dy is equal to this. So that means du over 2 is equal y dy. So this is du over 2. Take the 2 out, half. So now you have du over u. You know that the integration of this one is ln u, isn't it? So this is half ln u. But what's u? U is what? X squared plus y squared. From the properties of logarithm, this comes here. So this is ln x squared plus y squared to the power half. But you know, we can write this one as the square root of x squared plus y squared. This is the result of the integration. So this is ln x squared plus y squared under the square root. And this is from where? From 0. By the way, yeah, from 0 to 2x. That's it. This is what you get. So you see what I did? You see this x, I kick it out. I don't want it. So I kept my question as 1 over x squared y dy. I took this one as u, and then I simplified it. I got this answer. So now this is x. Now what do? We replace, don't forget, we are integrating with respect to y, so we're going to replace every y with 2x. So this is ln square root of x squared plus 2x all square minus ln square root of x squared plus 0 square. See what we did? We replaced first with x, 2x, and then this one. So this is x times ln square root. This is x squared plus, if you square this one, what do you get? You get 4x squared minus ln square root of x squared. And this is equal to ln, this is 5x squared, isn't it? Minus ln square root of x squared, and you have done. This is the final answer, guys. So we were able to integrate it. All right. Evaluate this integral where R is the region bounded by. Let's graph the region and see what kind of region I'm going to use and how do I integrate it. We have y equal to x. So this is the x-axis and this is the y-axis. Y equal to x, here it is. This is y equal x. I'm going to put it on the side because just not to mess up the graph. Y equal 0, we know this is what? The x-axis. So this one is y equal to 0. And x equal to 1, this suppose this is 1. So here is x equal to 1. So here is x equal to 1. This one now, y equal x. And this is y equal to 0. Where is the region? This is the region. So what do we say? So the volume here is equal to the double integration. What are you going to consider this? Type 1 or type 2? It's up to you. So let's take it type 1. Let's start from here, like that. Vertical, lighter. Where is it going to start with on the x-axis? So I'm going to say this is x cubed plus y squared. Then dy dx, because I took this one as a region of type 1. So for the x, we're going to start from 0. And we're going to stop here, isn't it? The last light is going to be here. So it's going to continue all the way till it stops here at 1. Now let's look at the length of this one. This light, as long as it's walking here, it's always touching this line. And who's this? This is y equal to 0. Up to what? Who's the height? The light. What's the height of the light? Who's the top of the light? It's y equal to x. That's it, done. Now what do we do, guys? We close and we integrate with respect to what? With respect to y. So we close. So this is equal integration from 0 to 1. What's the integration with respect to y now? X cubed. It's x cubed y. Let's open the box here. X cubed y plus, what's the integration y square? Y cubed over 3. And this is from 0 to x dx. Now, this is equal to the integration from 0 to 1. We replace each y with x because we are integrating with respect to y. So I'm going to replace here with x. So this is x cubed x plus, also put x here. So x cubed over 3 minus, what do? We replace y with 0. So it's x cubed times 0 plus 0 cubed over 3. And we close and we say dx. We know all of this is 0. So what's the final thing here? It's integration from 0 to 1 of x to the 4 plus x cubed over 3 dx. Now, you see, it's only one variable. The integration of x to the 4 is x to the 5 over 5, plus the integration of this one is x to the 4 over 4, but there is already 3, so 12 from 0 to 1. Put the 1, you get 1 over 5 plus 1 over 13. Put the 0, you get 0. And then the least common between these two probably is, let's see, what's the least common? That's the product of those two. So 5 times 13 is 65. So multiply, so this is going to be 13 plus 5. So the answer is 18 over 65. This is the volume of the solid that is bounded above by x cubed plus y square. And at the bottom, this is the base of it. Looks like this triangle. All righty, let's look at this one. This is the upper part. We don't care about it. This is the surface on the top. But look at the region. The region bounded by y equal x squared and y equal x cubed. So let's graph these two guys. As usual, we take the y-axis and the x-axis. All right, and then we start the graph. All right, y equal x squared, that's easy. Y equal x squared. Y equal x cubed. Maybe I should make it, okay, y equal x cubed is going to be the bottom one. So this one is y equal x squared. Let's go to y equal x cubed. Y equal x cubed is going to be a little bit down, right? So it goes like that, and then it goes like this, right? And then goes like this. This is y equal x cubed. So what's happening here? This is the region that I'm looking for. My region is bounded by these two curves. So this one is y equal x cubed. Now it's up to you to take a region of type 1 or region of type 2. Why do I have to make it type 2? Let's make it type 1 because y. So what I'm going to do is I'm going to take now a vertical light. The vertical light is going to start from here, isn't it? What is this? 0. It will definitely stop there, isn't it? The final stop is here, the intersection between those two. What is this point on the x-axis? So the light is going to start from 0, continue till it stops there. What is this intersection point? All right, you have y equal x squared and y equal x cubed. Where do they intersect? Since the left is equal to the left, so x cubed is equal to x squared. Move x squared to the other side. So you have x cubed minus x squared is equal to 0. Take x out, so you have x squared minus 1 is equal to 0. That means x equal to 0, or x squared minus 1 is equal to 0. From this one, x is what? Plus and minus 1. Here is x equal to 1, and there is no minus 1. So let's do now the volume. It's double integration of 6x plus 4y plus 1. Now I took it a region of type 1, so I'm going to say dy dx. It's a region of type 1. Okay. For the x, starts from where? We said from 0 to 1. We already finished it, from 0 to 1. How about the y? Who's at the bottom? Y equal x cubed at the bottom. And y equal x squared is the top, isn't it? This is y equal x squared, the red one. And the top one is y equal x squared. That's it. Done. This is the height of the blue light. The height is from y cubed at the bottom, y squared on the top. Now let's integrate. How do you integrate this one? We start from the inside. We integrate with respect to y first. So what do we say? So this is equal to the integration from 0 to 1. Let's integrate this one with respect to y. 6x is all constant, guys. So 6x, we don't touch it. So what's the integration of that? It's y. Because the integration of 1 dy is y. How about this one? Plus the integration of y is y squared over 2. Plus what's the integration of 1 dy? It's y. And this is from x cubed to x squared. And we say now what? Dx. Now what do? We replace first each y with x squared. Each y. So you have 6x x squared plus this one, by the way, with this one is 2. So plus 2. Replace x squared here. X squared, all square is x to the 4. Replace x squared here, you get x squared minus open bracket. Now let's replace y with x cubed. So you have 6x x cubed. Now x cubed all square is 2x to the 6 plus x cubed dx. And this is equal to the integration from 0 to 1. This one is 6x cubed plus 2x to the 4 plus x squared minus 6x to the 4. Minus with minus is minus 12x to the 6. Minus with minus is minus x cubed dx. So now let's look at the x cubed. 6x cubed minus x cubed is 5x cubed. 2x to the 4 minus 6 is minus 4x to the 4. Who else do we have? Am I missing something? Yeah. How about x squared? We don't have, so plus x squared, here it is. Done with this one. Now you have minus 12x to the 6 minus x cubed. Oops, we have x cubed. We finished that one, so we're going to remove that one. I remember I took it, so I don't know why I'm writing it again. Dx. Again, 6x cubed minus 1x cubed is 5x cubed. 2x to the 4 minus 6 is minus 4x to the 4. X squared, there is nothing. Then minus 12x, there is nobody. Now we integrate. The integration of x to the 3 is 5x to the 4 over 4 minus the integration of this one is 4x to the 5 over 5 plus x cubed over 3 minus 12x to the 7 over 7. And this is from 0 to 1. What do we plug first? We plug the 1. So you have 5 over 4 minus 4 over 5 plus 1 over 3 minus 12 over 7. Of course, minus the 0. Now, I don't know what is this. I leave this one for you to simplify and get the answer. All right, let's do this one, guys. Integrate this one where R is the region bounded by this one. So let's graph that thing here. y equal to 0 is, as we know, it's the x-axis. So this one is y equal to 0. Y equal to 1, let's say here is 1. So this is y equal to 1. So this one is y equal to 1. X equals 0. This one is x equals 0. X equal to 1. This one is x equal to 1. Where is the region between them? It's that square that you see here. It's actually a square. All righty. Now what do? We say that the volume is the double integration of y over 1 plus xy. Then look what I'm going to do now. If I look at the derivative, okay, if you want to treat it as y, what's the derivative of the denominator with respect to y? So if we say, let me just put it and show you. If I say dy dx, can we integrate this one with respect to y? Maybe we can, but it's really long. But if I integrate with respect to x, look what's going to happen. The derivative of the denominator with respect to x is what? Isn't it y, which is on the top? So I'm going to start with dx and then dy. Why is that? Because it's easier to integrate this way. So I'm going to take this one as a region of type what? Type 2. I will show you in the integral what do I mean by that one. So I took it as a region of type 2. Then I know that my sector or my light has to be a horizontal light, isn't it? My light is going to be a horizontal light because I'm going to treat it as a region of type 2. Okay, so y starts from where? The light is going to start from y equal to what? 0 up to y equal to what? 1. So the light is going to keep on moving all the way till it reaches the top, which is 1. Okay, now on the left, the length of this light on the left is x equal to what? 0 up to x equal what? 1. Here is 1. Done. So this is exactly the integrand. Now we start from inside. This is equal to the integration of 0 to 1 of now. Look what I'm going to do now. On the side here, I don't know which side I'm going to take. So let's do here, guys. What's the integration of y over 1 plus xy with respect to x? I will take the denominator, call it u. Let's differentiate the denominator with respect to x, guys. Okay, we're integrating with respect to x, so we differentiate with respect to x. What's the derivative of 1? 0. What's the derivative of x? 1. So left what? We left with y. Bring dx here. So du is y dx. Very nice. Du is y dx. So what is this going to be, guys? This is the integration. I call the denominator u. How about the numerator? What's y dx? Isn't it du? Look how beautiful it is. What's the answer of that? It's ln u. And what's u? U is 1 plus xy. So the answer is ln, of course, with absolute value of 1 plus xy. This is the answer for this one. So the answer is ln 1 plus xy. And this is from 0 to 1 dy. And this is equal to, you see, this is why I chose x. This is integrable now. So this is the integration from 0 to 1. What do we plug first? 1. For who? I integrated with respect to x, so we replace 1 for x. So this is ln 1 plus y minus ln. What do we do now? We replace x with 0. So 1 plus 0y, which is 0. And we say what? dy. This is what ln 1. Ln 1 is what? Is 0. So this is gone. So I'm now here. So this is equal to the integration from 0 to 1 of ln 1 plus y dy. Now, how do you integrate this one? This is the headache now. This is integration by parts, right? So the final answer is integration by parts. How do you integrate this one by parts? Usually you let u equal always this function, ln 1 plus y, and dv is the leftover, which is dy. So du is equal to the derivative of this one is 1 over 1 plus y. Okay, and we can say here dy, and v here is y. So what's the integration of ln 1 plus y dy? It's u times v, which is y ln 1 plus y, minus the integration of v dy, which is y over 1 plus y dy. Now another headache. How do you integrate that one? Let me do it here on the side. What's the integration of y over 1 plus y dy? Remember, this is called improper function. You can't have y over 1 plus y. The degree of the denominator, the numerator must be less. They have the same degree. So what do we do? On the side, we will divide y by y plus 1. Y divided by y is 1. 1 times y plus 1 is y plus 1. See, this is what we divide. Y divided by y is 1. What do we do with 1? We multiply it by everything here. So you get y plus 1. Subtract. This y goes with this one. Now 0 minus 1 is negative 1. So what is this equal to? This is equal to the quotient, which is 1, plus, or it's going to be minus 1 over the divisor. This is the integration, guys, dy. Now, what's the integration of 1? It's y, minus. What's the integration of this one? It's ln the denominator. This is the answer. So this is going to be y ln 1 plus y minus whatever you get here. So minus y plus ln 1 plus y. Alrighty, so this is what we have here. So we're going to put it there. So this is equal to y ln 1 plus y minus y plus ln 1 plus y, and this is from 0 to 1. Put the 1 first. If I put y 1, what do we get? We get ln 2. It's going to be 1 ln 2 minus 1 plus ln 2. Now put the 0 minus. Put the 0. If you put y 0, it's gone. 0. Put the 0 here, it's gone. Put the 0 here plus ln 1, isn't it? But ln 1 is 0. So 2 with 2. So this is 2 ln 2 minus 1, which is equal to ln 4 minus 1, isn't it? Ln 4, because this 2 goes up, will be 2 squared, and this is the answer, guys. It's ln 4 minus 1. Let's do this one. All right. Now, the region is bounded by y equal x, x equal minus y. You know, that means y equal minus xy. So this is y equal minus x, y equal x, and x equal root 3. If this is 1, this is 2. Root 3 is 1.7 somehow here. Let's say this is root 3. So it goes up like that and goes down. So where's my region? All of this is my region. What do? We're going to say the volume is equal to the double integration of square root of x squared plus 1. By the way, this could be integrable with respect to x, but it's hard. You have to use trig substitution. So I'm not going to put dx. I'm going to say dy dx. With respect to y, I can integrate it, but with respect to x, I can't, because the derivative of x squared plus 1 is not there. So this is not integrable with respect to x easily, but with respect to y, it's going to be easy. Why is that? Because all of this is constant. So I took it as a region of type 1, as you see. Type 1 means what? My sector is going to be a very perpendicular sector. So the sector is a perpendicular sector. It's going to start from here. From where? From 0. And it's going to keep on. Where is it going to stop at? Who's this? This is x equal what? Root 3, isn't it? So for x, it's from 0 to root 3. This is the light is going to continue moving to cover the whole thing. Now, who's at the bottom? This is y equal what? Negative x. So from negative x to the top, we know the top is y equal x. So this is x. Done. This is, guys, how you integrate it. Now, what do? We put a box inside. So this is equal to the integration from 0 to root 3. Now, all of this is constant. I'm integrating with respect to y. So we keep it as x squared plus 1. We don't touch it. And now, what's the integration of dy? It's y. That's it. From negative x to x. And then what do we say? dx. Got it? I'm integrating with respect to y. So what is this all? It's just garbage. Keep it out. Don't touch it. The integration of dy is y. Here it is. Now we plug x. So this is equal to the integration from 0 to square root of 3. I'm going to replace y with x because I was integrating with respect to y. So it's going to be square root of x squared plus 1 x minus. Now put the x here. So it's going to be square root of x squared plus 1 times minus x dx. Minus with minus is plus. So this is the integration from 0 to square root of 3 of x squared plus 1. Now times x and times x. This is plus. So this is 2x dx. Let me put the 2x at the beginning, at the end. So you will see what's going on here. So here is 2x dx. All right. How do you integrate this one? I'm going to do it here. The integration of x squared plus 1 times 2x dx. You let u equal what's inside the radicals, right? So du is what? It's 2x dx, right? The derivative of x squared is 2x. Here it is. So what's this going to be? This is square root of u. 2x dx is du. All right. What's the integration of u to the half? It's u to the 3 over 2 times 2 over 3, which is 2 over 3. What's u now? U is x squared plus 1 to the 3 half. This is the final answer. So this is equal to 2 over 3 x squared plus 1 to the 3 half from 0 to square root of 3. What do you plug first? Square root of 3. So this is 2 over 3. If I put square root of 3 for the square, what do we get? We get 3 plus 1 to the 3 half minus 2 over 3. Put the 0, you get 1 to the 3 half. I'm replacing now next with 0. This is 4. So this is 2 over 3, 4 to the 3 half minus 2/3 because this is 1. Now 4 to the 3 half. 4 is 2 square, isn't it? To the 3 half. This 2 goes with this 2. You're left with 2 cubed, which is 8. So this is going to be 2 over 3 times 8 minus 2 over 3. So this is equal to 16 over 3 minus 2 over 3. And this is 14 over 3. This is the answer for this question. This is the volume of this solid. One more question. Find the volume of the solid bounded by yz equal to 6. So I know here that z will be 6 over y. That's the inside. So I know that the volume is going to be to the double integration. Always z goes inside. Then we say dA over what? Over R. Now let's look at the situation we have here in our region. Now these are all for our region. So let's graph it. What's the first one? X equal to 0. This one is x equal to 0. It's the y-axis, right? This one is the y-axis. X equal to 5. Here is 1, 2, 3, 4, 5. Here is the 5. This one is x equal to 5. Y equal to 1. Here is 1. Y equal to 6. 2, 3, 4, 5, 6. Here is y equal to 6. Where is the region that's surrounding all of that? It's this region. Alrighty, so what do we do now? We can do both ways, type 1 or type 2. So I'm going to say this is 6 over y. If I integrate with respect to y, then there's going to be ln y. I don't want to start with ln, so I'm going to start with what? dx dy. Why is that? Because the integration of 6 over, because 6 over y will be constant. So what's the answer? 6x over y. That's easy to integrate. So I'm going to consider it as a region of type 2. Okay, look inside here. If I want to integrate this one, that's easy. 6 over y, the integration of 6 over y, x, right? So now we can make it a region of type 2. Region of type 2 means what? Means we are going to have a horizontal light. This light is going to start with y what? This is y equal 1 on the outside. Up to y equal to what? It's going to go all the way up to cover the whole region horizontally. Up to y equal to 4, 6. This is y equals 6. All right. For the x, who's on the left? X equal to 0. Who's on the right? X equal to 5. That's it. So now let's integrate, guys. So this is the integration from 1 to 6. Open the box. 6 over y, if we are integrated with respect to x, 6 over y is a constant, guys. We don't integrate it. What's the integration of dx? It's x. From where? From 0 to 5. And we say what? dy. Now what do? We plug the 5. So this is equal to integration from 1 to 6. Put the 5 first. So it's going to be 30 over y minus. Put the 0, you get 0. dy. So this is going to be the integration from 1 over 6, 30 over y dy. We can take the 30 out and just 1 to 6 of 1 over y dy. We know that the integration of 1 over y is ln y from 1 to 6, which is equal to 30 ln 6 minus ln 1. Ln 1 is 0. So the final answer is 30 ln 6. You see, if I started with dy dx, then the first integral is going to be what? Ln. And if I have ln, then the second integral, when I integrate, I have to use integration by parts. I don't want to do this like what we did in the previous one. So I started with dx over dy. See how challenging the questions are? Last question, guys. I know it's long, but this is our last question. To integrate with respect to y, there is no way, right? Because in the denominator, you have y plus 1 plus y squared. You could do it by integration by substitution, trig substitution. But I don't want to get involved with this. So the derivative of the denominator is not in the numerator. So to treat this one as a constant, I have to switch, guys. This cannot be integrated with respect to y. With respect to y, it's impossible. So I have to switch. So what do I say? So this is equal to the integration of 1 over 1 plus y squared. See this dy dx? I'm going to switch it as dx dy. When you switch it, it's not an easy thing. So how do I switch it, guys? Look what happens. dy dx, this is a region of type 1, isn't it? Now I'm going to make it a region of type 2. Now, since it is a region of type 1, let's graph and see what's going on. All right, x is from where to where? X from 0 to 1. So here we have x from 0 to x equal 1. X equal to 0, this one. To x equal 1, here it is. Okay, don't forget that was the region of type 1. Now, for the y, it's from x, y equal x. Here's y equal x. So it's from y equal x to y equal what? 1. Where is y equal 1, by the way? This is y equal to 1. So where's my region? Be careful. It's from 0 to 1. Y equal x. This is y equal x to y equal to 1. So I know it's you might think it's here, but you see, we need x. If you go here, x equal 1 might not be included. So you need this one to be included. So actually, this is your region. All right. From 0 to 1, y to this one at the bottom, y equal 1 at the top. Okay, so my apology here. We think properly. I think sneezing makes it difficult. All right, so let's look again. And I'm going to change the color actually to see where we are. All right. Now x equal to 1, here it is. Also, this could be x equal to 1 and start from x equal to 0 to x equal to 1. Then y equal to x, here it is, up to y equal to 1. So I have to include this one. So this is actually my region, the top one. Because if I go here, y equal 1 will not be included. So we're going to be here. So I'm going to treat this one. By the way, you cannot integrate this one. So I'm going to switch. So this is exactly region of type 1. So it was like that. This is the light. So the light will go like this. This is how the question is set to be. I'm going to switch. So I'm going to switch and make it region of type 2. So what do? We will take now horizontal thing. So what's this going to start with? The light is going to start with here. And who's this? This is x equal to 0. So sorry, this is y equal to 0. For the y, it's a 0. Up to y equal to what? 1. This is y equal to 1. How about x? You start from the left with x equal to 0. What is this? This is y equal to x, so x is equal to y. So up to y. Got it? Now, what do? We close inside and we integrate. So this is the integration from 0 to 1. Now this is all constant. What's integration of dx? It's x. So we're going to say it's x over 1 plus y squared. We don't touch 1 over y squared. It's constant. From 0 to y dy. Now what do? We replace x with y. So this is the integration from 0 to 1 of y over 1 plus y squared minus, put the 0, you get 0 over 1 plus y squared dy. But this is all 0. So I have the integration from 0 to 1 of y over 1 plus y squared dy. Now, how do you integrate this one? I'm going to let u equal 1 plus y squared. So what's du? It's 2y dy. Look at the question. I have y dy. See? We have y dy. So I'm going to divide by 2. So du over 2 is y dy. So what is this going to be? The integration from 0 to 1. I took the denominator to be u. The numerator y dy is du over 2. So the half is going to go out. And this is equal to half. The integration of this one is ln u, as you know, from 0 to 1. But what's u? U is 1 plus y squared from 0 to 1. I can bring the half out. So this is ln square root of 1 plus y squared from 0 to 1. You see, I can bring the half out, so it's square root. Put the 1. So this is ln square root. If I put 1 here, you get what? Ln 2 minus ln. Put the 0 here, you get square root of 1. But square root of 1 is 1 and ln 1 is 0. So the final answer is ln square root of 2. Thanks, guys, for joining me in this journey. I I try to put as many examples because you need to know how to integrate and how to find the volume, how to switch, how to integrate one side, how do I integrate when I have a function of x and consider y as a constant. These things are important to know and understand in this section so that we can proceed with the next section. We'll see you then in 9-11 next. Thank you, guys. Have a good day.